Hi, welcome to the part of Module 8 where we talk about the future and some climate change agreements, as well as options for how to reduce CO2 emissions. So our learning objectives for this submodule are going to be to describe different approaches governments can use to encourage greenhouse gas reductions. And these can get very technical, so we're going to keep them kind of broad stroke, but kind of big picture ideas. We'll introduce the Montreal Protocol, one of the first climate emissions reductions agreements, and talk about how it worked. We'll understand what role the acronyms you may have heard, like the IPCC or the UNFCCC, what they are and what role they play in current emission reductions agreements. And we'll identify the main sources of CO2 emissions globally and the main sources of energy production emissions. And so we'll talk then about the concept of geoengineering and explain some of the benefits and pitfalls inherent in it. Something like a last resort approach that people are getting more and more into researching and even trying. So we've got two examples of international agreements on emissions that have taken place and have been successful. And I'm introducing these more so to just show that these sort of things can work, although there are some key differences. So the examples are the Montreal Protocol that was originally started in 1987. This was to reduce and eventually ban the use of chlorofluorocarbons, CFCs, that were eating a hole in the ozone. And then we'll also talk about the US-Canada Air Quality Agreement. This was a 1991 agreement that was tackling the problem of acid rain, which you all likely have not heard of, but certainly when I was growing up, this was a big thing, that there was really acidic rainwater coming down and killing fish across the US and Canada. So Montreal Protocol, these are plots of CFCs, chlorofluorocarbons, going up in over the late part of the last century, in starting the 60s, but then continuing to go up through the 80s into around 1990 or so. These are used in refrigerants and aerosol sprays, and the problem is that they break down ozone in the atmosphere. And ozone is really important. It blocks UVB and UVC. This is ultraviolet radiation that can cause cancer. It causes burns, but eventually it causes cancer. So ozone is really important to us, and it was causing a major hole in the ozone. Now, this Montreal Protocol was signed in 1987 and had a stepped reduction of CFC production by 20% by 93, 50% by 1998, and then in 2017, they were at about 99% reduction. It's been updated since to account for different types of fluorocarbons that were continuing to eat holes in the atmosphere, and has largely been quite successful. So if we look at atmospheric concentrations, they're still taking time to come down. SF6 is used in other types of industrial processes. This is still going up, but will hopefully come down in the future too. It's also present. This is in parts per trillion for SF6 versus, it's in a much lower scale. They're both parts per trillion, but it's almost an order of magnitude smaller amount of SF6. So this has been overall a success story. The ozone layer does seem to be bouncing back. The hole is closing, although it's not like it's a entirely linear process, but projections are that it should be largely closed in another, say, 30 years or so. So long-term issue, but something that points to an international agreement where we at least stopped emissions of something, and seems to be working. As a side note, CFCs have been used in oceanography to trace water masses. So these are results from a model, though one that actually agrees quite well with actual observations in the ocean. So this is on the upper left. These are the CFC. This is one type of CFC's content in the atmosphere. It goes up and then down over time. And then this is looking at a section in the ocean. So looking in the Atlantic, from the North Atlantic down to the South Atlantic. So latitude is on the x-axis, depth on the y-axis. So we're looking in the ocean, and essentially the darker color is the reds, purples, or higher concentrations of CFCs. And so as CFCs are absorbed into the ocean, as they dissolve in, they trace the formation of North Atlantic deep water, and you can use them to, if you know what the atmospheric concentration is and how that's changed over time, you can use that to trace the water masses and understand how old they are. So it's pretty cool. It's kind of one of these accidental uses of something that's entirely man-made. There's a number of other examples that we use in chemical oceanography for, we call them anthropogenic tracers, but not really related to our climate agreement talk, but still very interesting. Okay. So the second climate agreement that we want to talk about is the U.S.-Canada Air Quality Agreement. And the problem was that sulfur dioxide and nitrous oxide emissions from power plants were reacting in the atmosphere and forming acidic compounds that then rained into lakes and streams and rivers and killed fish. It's really becoming a problem. This map shows where the biggest issues were, and it was really around power plants in the northeast US and southeast Canada. Overall, the agreement has really reduced these emissions. This has been through a mix of increases in efficiency, pollution controls, change in fuels. And so this, again, is an example. It's not the whole globe, just two countries, but where we've had emissions of something that was causing harm, and we dealt with it. Now, so we do have concrete examples of international cooperation to reduce gas emissions, where we had a problem, we were emitting something that was causing harm, and we stopped the emissions. And so that's, to me, that's encouraging. Like, it's something we've done before, and we have experience doing it, and that's reflected in the climate emissions agreements that have happened that we'll talk about in the next video. A few important caveats, though, is that, one, in both of these cases, once we remove the source of the pollution, we let nature do the work afterward. So we didn't clean anything up, we just stopped making things worse. And for CFCs or sulfur dioxide, they're relatively short-lived in the atmosphere. And so they didn't stick around for a long time, they broke down or were just absorbed. And so it became, the problem sort of took care of itself once we stopped making things worse. That won't really work with carbon dioxide. The lifetime of carbon dioxide, how long it sticks around in the atmosphere, is on the order of thousands of years. So we put molecules of CO2 in the atmosphere right now, we can't rely on nature to just take care of it. Now, if we stopped emitting more CO2 right this second, we would stop additional warming. So there's definitely huge benefits to stopping warming or stopping emissions. But if we want to return to something like the world that we used to have, we'll have to actively take up CO2 at some point. That said, the first priority is just stopping emissions. The second difference is the connection between emissions and negative impacts was relatively more direct. You emit CFCs and they break down to ozone, and that's a problem. You emit sulfur dioxide, nitrous oxide, and you get acid rain and fish die. That's a clear problem. With CO2 emissions, I think people have been, a little bit of warming is harder to say, harder to tell someone it's really bad than, say, acid rain or UV radiation burns. So that makes it a little bit more difficult, and it's more of an indirect connection, especially when you start talking about impacts on, say, weather or ocean acidification. And CO2 is also just much more ingrained in everything we do, right? For the duration of humankind, when you burn stuff, you release CO2. You make energy in most ways, you release CO2. We in every aspect of our life, we emit carbon dioxide, whether we realize it or not. And so it is that there are definitely improvements there, and we'll talk about those in a few minutes. But it's harder to disentangle ourselves, and that's, I think, part of why this has been slow going. But we have some examples of past agreements, and in our next video we'll start talking about current agreements and where things are headed.